Okay, sure. We see the next method, second method to find particular integral, that is the general method. Is this clear? Everything is good? No problem?
Yes, ma'am.
Okay, sure. So we start now. So the second method is the general method, and whenever the functions are like the functions which we have not covered in shortcut methods. So we have covered which type of functions. The first one is e raised to, then sine cos, then hyperbolic sine cos, and then polynomial, and then e raised to x into v, and then x into v. Only such type. And last one is x raised to m cos or x raised to m sine. Right? Such functions have covered. But the functions except this, if such functions comes, then we have to solve them by using general method. For example, you say sec, cosec, log, such functions, if they are there, we have to solve them by general method. So general method, whenever you get any equation phi dy is equal to f of x, you know the half part is yc. To find yp, yp is 1 upon phi d into f of x. We know this, and this method is to find yp only, right? So we concentrate on yp. So we have to factorize factorize the denominator. Factorize the denominator. This part. What is factorization then? We have seen the roots. We have find out the roots. That roots, using that roots you can write the factors. So if say roots are d is m1, m2, so on, or say m3, these are the roots, then its factors are that phi d is also okay. If roots are m1, m2, m3, then phi d can be written as d minus m1, d minus first root, into d minus m2 into d minus m3. So how many roots are there? That many number of times the multiplication will be there of the factors. This is called factorization. So depending on the roots, we can write the factors. Just that root, write it minus to d. That will be the factors. Okay. So try to factorize the denominator. So if after factorization you get something like d minus m f of x, only one factor is there, say d minus m. If something is there, it has a formula, and that is called the general method formula. So formula is 1 upon d minus m f of x. Pay attention, that m e raised to mx. If it is minus m e raised to mx, integration e raised to minus mx into f of x dx. This is the formula. Note down this. 1 upon d minus m f of x is e raised to mx integration e raised to minus mx into f of x dx. This f of x. And this term याच्या वर्ण लिहिली आपण डिनॉमिनेटर मधल्या m वर्ण. Okay. Second formula 1 upon d plus m f of x. If it is plus m, e raised to minus mx outside and e raised to plus mx inside integration into f of x dx. Second formula. Okay, if this is so. But if there are two factors or three factors, then what to do? So, for example, if it is say 1 upon d minus m1 into d minus m2 f of x. Then what you can do is there are two ways. The first is factors inside outside. One factor you can take in and one factor let outside. Okay, operate this first by using this formula, complete this and operate the outside. That is 1 upon, let this as it is, d minus m1, operate this. This is the formula here, m is m2. So it is e raised to m2x integration e raised to minus m2x into f of x dx. Okay, and then again there is d minus m1. Finish this part first, integrate, write the answer, and then apply this factor, outside factor. How do we apply it? D minus m1. Formula says this is your new f of x. D minus m1 of f of x. It is e raised to m1x integration e raised to minus m1x into this f of x as it is, e raised to m2x integration minus m2x f of x dx into dx. This is the formula. Either inside outside, this is the first way. Complete this by using the formula, again complete this by using the formula. This will be your new f of x. That is the first part. We call it as factors inside outside. And if second is, if there are two such factors, then the second way is partial fraction. partial fraction मध्ये काय करतो, दोन जर डिनॉमिनेटर असतील असे तर ते आपण सेपरेट करतो. दिस टू हे सेपरेट होतं पार्शियल फ्रॅक्शन. कसं सेपरेट होतं, 1 अपॉन डी मायनस एम वन इंटू डी मायनस एम टू असं जर असेल तर याला लिहितो आपण, हा लिनियर फॅक्टर आहे, ए अपॉन डी मायनस एम वन प्लस बी अपॉन डी मायनस एम टू. हे माहिती तुम्हाला पार्शियल फ्रॅक्शन मेथड.
येस मॅम.
डी ची जर लिनियर टर्म असेल तर वरती कॉन्स्टंट येतात, मग हे क्रॉस मल्टिप्लाय होतं, ए इंटू डी मायनस एम टू प्लस बी इंटू डी मायनस एम वन इज इक्वल टू 1. राईट, मग आपण काय करायचंय, डी ला एकदा एम टू ठेवायचा आहे, व्हॅल्यू ए ची किंवा बी ची व्हॅल्यू मिळेल, व्हॅल्यू शोधायची, आणि डी ला एकदा एम वन ठेवायचा आहे. ठीक आहे, मग दुसरी व्हॅल्यू मिळेल. ए बी फाइंड करायचंय, इथे ठेवायचंय, मग हे डी मायनस एम वन सेपरेट होईल, डी मायनस एम टू सेपरेट होईल, आणि मग सेपरेट फॉर्म्युला तुम्ही यूज करू शकता. हा आपला फॉर्म्युला सेपरेटली यू कॅन यूज. Okay, so these are the two ways. Just important is two types. One is factor inside outside. Either you can do this or you can use partial fraction. And the important is this formula, these two formula. General method is only this formula, nothing else. Everything you try to convert into such form and use the formula and solve. Okay, so we go to example. Write down example. Solve. D square plus 3D plus 2y is equal to e raised to x. D square plus 3D plus 2y is equal to e raised to x. Okay. The first thing is function is of the type phi dy is equal to f of x. This is the equation. So its general solution is y is yc plus y. So to find yc, you have to consider auxiliary equation. And find the roots. Tell me the roots, please.
-1, -2.
Very good. -1, -2. So therefore, can you just tell me complementary function, YC?
As it is
C1
C1
e
e
raised
raised
to
to
minus
minus x
1
plus
plus C2
C2
e raised to minus
minus 2
2
minus
x.
2.
X. Very good. Then now we go to YP. YP is 1 upon d square plus 3d plus 2 into e raised to x. Now, once such YP is there, we first check the type of functions. So this function is, first you check whether it is case 1, case 2, case 3. Does it come under any of the shortcut case? Check that. Can you see this is any of the shortcut case?
No.
No.
No, ma'am.
No. Right? We have e raised to ax. We do not have e raised to something. Right? So this is not the shortcut case. So we have to solve this by general. So for the general method, denominator you must write as the factor. So what are the factors of this denominator? For that, go to the roots. These are the roots. If you write d minus of the first root, d minus of -1, काय होईल ते मायनस ऑफ मायनस प्लस, हे झालं पहिला फॅक्टर इंटू त्याचा सेकंड फॅक्टर असणार आहे d मायनस ऑफ -2 प्लस 2. Do you understand how to write the factorization by using roots? If the roots were say 1 and 2, what will be the factors?
D
D
minus
minus
1 and D
1, D
minus 2.
minus 2.
D
Very
minus 2.
good. Very good. And if it is -1 and 2, then
D plus 1,
D
D
plus
D
minus 2,
1,
plus
D
1 D
minus
D
2.
minus
minus
2.
2.
d minus 2. Very good. So this thing we need in general method, the factorization into e raised to x as it is. Then there are two ways. Either you can separate the denominator by partial fraction, or you can let one factor out and you can take one factor in. We finish one factor and we operate the second one later. So we let this outside, we take this inside e raised to x. Anyone, let it out and take any one in. Try to finish this till you will let the first factor out as it is. Okay, this one. How can we use the formula now by general method? Can you just see the formula once? 1 upon d plus m f of x. 1 upon d plus m f of x. E raised to minus mx integration e raised to mx into f of x dx. Here. So apply this. M is here 1. E raised to
Minus 1.
minus 1x, yes, integration e raised to
E raised to
1x,
minus
मायनस
1x.
बाहेर आतमध्ये प्लस. ओके, प्लस असेल तर मायनस बाहेर आतमध्ये प्लस इंटू युअर फंक्शन e raised to x dx. Are you clear with this step? The formula. Take your time. Just everyone be clear with this formula, whatever I have used. 1 upon d plus m, 1 upon d plus m f of x. M is here 1. If it is 1 here, d plus 1, it is e raised to minus 1x integration e raised to 1x into f of x dx. E raised to minus x integration e raised to x f of x dx. Everyone is clear?
Yes, ma'am.
Yes, ma'am.
Yes,
Good.
ma'am.
So can you just tell me how do we solve this integration? Now your job is to find out this integration. How to solve? Generally, integrations can be solved very oftenly by substitutions. So is there any such function? So we substitute and we can solve. What will be the substitution? जे कॉमन दिसतंय ना ते सबस्टिट्यूशन असावं. आता हे जर बघितला तुम्ही ई रेस टू एक्स, हे थोडस कॉमन फंक्शन आहे का? म्हणजे असं जनरल यूज मधलं तुम्हाला दिसतंय का? आपण नेहमी बघतो का याला? हे स्टँडर्ड असं ई रेस टू एक्स असेल तर स्टँडर्ड वाटते, पण ई रेस टू एक्स पाहिलं तर काहीतरी वेगळं वाटतंय. म्हणजे वेगळं वाटतंय त्याला सबस्टिट्यूशन करा. काय वेगळं वाटतंय? हे याच्या पॉवर मध्ये हे वेगळं वाटतंय. ई रेस टू काहीतरी चालेल, पण ई रेस टू एक्स थोडं वेगळं आहे. सो काय करूयात, जे वेगळं वाटते त्याला सबस्टिट्यूशन करा. सो पुट ई रेस टू एक्स इज टी. ओके, टेक डेरिवेटिव्ह ई रेस टू एक्स dx is equal to dt. Correct? And this is only for the integration. So where do we do the substitution? Only inside integration, not outside of it. This whole thing is for integration only. So put it in the integration part. D plus 2 e raised to minus x integration e raised to याच्यासाठी ठेवूयात पहिलं e raised to x, but e raised to x is t. So this is e raised to t into e raised to x dx is what? dt. Are you with me, everyone? Do you understand? This e raised to x is t, so it is e raised to t, and e raised to x dx is dt. So for this it is dt. Clear? Okay, then integration. Outside as it is. What is integration e raised to t? Integration of e raised to t. Integration formulae here.
E raised to t plus 1 upon t plus
No,
1.
no, no. Integration.
e raised to t plus
ओय, तुम्ही मला हे सांगताय
E.
इंटिग्रेशन एक्स रेस टू एन सांगताय तुम्ही मला एक्स रेस टू एन प्लस वन अपॉन एन प्लस वन. हे एक्स रेस टू नाहीये, हे ई आहे. ई आहे हा
e
ई.
raised to t च येणार ना मॅम.
येस, इंटिग्रेशन ई इज ई इटसेल्फ. डेरिवेटिव ऑफ ई इज ऑल्सो ई इटसेल्फ. ठीक आहे. सो इंटिग्रेशन ऑफ ई रेस टू सपोज ए एक्स जर असेल ना, तर तो ई रेस टू ए एक्स अपॉन ए होतो फॉर्म्युला. पण इथे आपल्याकडे ई रेस टू वन टीज आहे की नाही. सो विथ रिस्पेक्ट टू टी इंटिग्रेशन आहे. सो ई रेस टू टी अपॉन वन, नो नीड टू राइट दैट अपॉन वन. सो इट इज व्हाट, integration of this is e raised to t. But we are totally in the variables x and y. This t is what we have substituted, so we should back substitute it to the original. So e raised to minus x as it is, and t was nothing but e raised to x. So I am resubstituting it. E raised to x. The first part is done. First factor is done. Now what we get this is new f of x, new function. Okay, so now we apply this factor on this function. How? Can you just apply and tell me? 1 upon d plus m f of x. Use 1 upon d plus m f of x. E raised to minus mx integration e raised to mx f of x dx. Same is used here also. So next step, it is equal to, can anyone tell me? 1
e raised
upon,
to minus
yes,
2
yes,
integration e raised to minus 2x
minus is done, now plus,
plus
plus 2x into f of x, whatever here, the whole function e raised to minus x into e raised to x dx. Now we have to solve the integration. Base is same, it is e raised to ax type both. So addition 2x minus x. 2x minus x is x into e raised to x dx as it is. Okay. Now again we have to solve this integration. To solve this integration, once again we do the substitution e raised to x as t. Therefore, e raised to x dx is dt, derivative. Substitute here, it is integration e raised to x is t, e raised to t into dt. But this integration of e raised to t is e raised to t. Okay, so it is e raised to minus 2x into e raised to t. T is but e raised to x, so e raised to x, which is your yp. These are over, done. This is the answer yp. So therefore, finally just collect your yc and yp is the general solution. If the functions cannot be solved under any of the shortcut cases, then you go for general method. Now, what is important according to online exam? This best big examples will not be there, but there will be this very important formulae. These two formulae you should not forget. For MCQ, any one of which can be there. So write it there star or mark something for MCQ type. This formula are very important. Okay, because we know that such questions cannot come under MCQ. We take the next question. Solve d square plus 3d plus 2y is equal to sine e raised to x. Okay, in between, can I ask you one question? Which one you think is better, Zoom or Meet?
Meet, ma'am.
This one, today's?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay, good.
Yes, ma'am.
Good, good. Chalo, we solve this question. So first thing is phi divides f of x type, means the general solution will be y is yc plus yp. We should find the roots now. Come on, find the roots and tell me.
-1, -2.
Very good. Similar one as previous. Therefore, yc again the same as last one. Okay. Then yp 1 upon d square plus 3d plus 2 into sine e raised to x. Which method? Shortcut method or general method?
General
Is there
method.
any, is
General
there any
method.
yes, is there any shortcut for such function? We have one shortcut, but this is for sine ax plus b, not sine e raised to x. These are very particular shortcut methods. Sine function should be sine ax plus b only, not sine of e raised to x. Okay, so here we can note this is by general method. You can write the reason also, as no shortcut case is used, so we can use the general method. Yes, as it is the general method, what is your next job?
D plus 1
Yes, factorize d plus
plus
1
1
into second is d plus
D
2.
plus 2.
Yes, sin e raised to x as it is. Okay, the first one we have seen by using factors inside outside. Now we can see the second type. What is the second type? I call it as one first. What is the second type? How to solve? एक the
factor
factor.
factorial
Yes,
trick.
yes. एक the fact. Yes, एक the factors inside outside you can do, or partial fraction by partial fraction. We first separate these two and we'll solve. So consider 1 upon d plus 1 into d plus 2 is equal to a upon d plus 1 plus b upon d plus 2. Right? Then just cross multiply a into d plus 2 plus b into d plus 1 is equal to 1. Now put, what is the first substitution? Put d is equal to such substitution जे तुम्ही इथे ठेवल्यानंतर हे 0 होईल आणि इथे ठेवल्यानंतर हे पण 0 होईल. These are the two substitutions. What is the first one?
-1
Minus 1. Yes. So put d is -1 in this and solve. So 1 is equal to a into -1 plus 2 plus b into -1 plus 1. This is 0. 2 minus 1, 1. A is equal to 1. So a is 1. We get the value a1. Now put in this, put d is next
-2
minus 2. Yes. So put d is minus 2 in this. So we get 1 is a into minus 2 plus 2 plus b into minus 2 plus 1. Minus 2 plus 2 गेला. Minus 2 plus 1 minus 1. So it is minus b is 1. That is b is minus 1. We have a, b, substitute here. Let us call it as 2. Call this as second. Therefore, 2 implies 1 upon d plus 1, d plus 2. A upon a is 1. So 1 upon d plus 1 plus b upon b is minus 1. Minus 1 upon d plus 2. Okay. This is, we have to substitute here 1 upon this value. So 1 implies yp is 1 upon d plus 1 कसं लिहिलंय ते 1 upon d plus 1 d plus हेच लिहिते मी पुन्हा एकदा d plus 1 d plus 2 sin e raised to x. But this can be now by using this. For this we can write this. So 1 upon d plus 1 minus 1 upon d plus 2 into sin e raised to x. This into this separate. 1 upon d plus 1 sin e raised to x minus 1 upon d plus 2 sin e raised to x. Just separate it. Okay. Now separate formula for this 2. First one. Can you just tell me the first formula? E raised to
-1.
yes,
-1
minus 1x integration हे मायनस झालं आतमध्ये प्लस.
X.
येस, इंटू sin e raised to x dx. Now for this minus for this e raised to
-2
minus 2x integration
e raised to
e raised
2x
to
sin
2x.
x
Very good.
dx.
Sin e raised to x dx. Now here is one, here is one. We have to solve these integrations. How do we solve? Once again, if you
Integration.
yes, we have to solve the integration. But once again, if you see something which is not normal, like sin ax plus b, this is normal thing. But if something is not normal, that normal should get normal by using substitution. So what is the substitution?
E
E
raised to
raised to
x is
X
equal
Yes,
equal
to t.
to
yes, very good. So put e raised to x, because this, if you can see, sin e raised to x is not normal. If sin t is there, it is normal. So put it as t. That is derivative e raised to x dx is dt. Okay, we substitute here. In both the integrations, we can do this. Sin e raised to x, sin e raised to x. In both the integrations, we can put e raised to x is t. So this is substitution for both of them together. E raised to minus x integration sin e raised to
Sin t.
x sin t, yes, into e raised to x dx. But e raised to x
dt.
dx is dt. Sin t dt minus e raised to minus 2x integration. Once again, बरं इथे पुन्हा एकदा लिहू का
Sin
मी
t.
जरा. Okay, here it is sin t, sin e raised to x sin t. E raised to 2x is e raised to x into e raised to x. एक स्टेप वाढवू का इथे. इथे लिहिते बघ. E raised to minus x, this is as it is, sin e raised to x dx, minus this as it is, into e raised to x into e raised to x into sin e raised to x dx. That e raised to 2x, we can write e raised to x into e raised to x, because we have substitution e raised to x. Now this is sin t. Okay, e raised to
T
x
square.
dx is dt. No, e raised to x dx is dt.
dt.
Dt, yes. This is done, this is done, this is done. But one e raised to x is there, which is nothing but
Remain
e raised to x is
t.
t. So this is t sin t dt. Are you getting? E raised to xt, so sin t e raised to x dx is dt into 1 e raised to x, which is t. Now you have to integrate this as it is. Integration of sine,
Minus cos.
yes, it is minus of cos t. Very good. Minus, this is as it is, e raised to minus 2x. And if you can see, there are two functions of t multiplied. Then two functions are there, t sin t. Leibniz rule वापरू शकतो. Can we apply Leibniz? Do you remember Leibniz rule? Integration uv is uv1 minus u dash v2 plus u double dash v3 minus so on. This is the formula, Leibniz rule of integration. बघितलाय ना आपण?
No, ma'am.
Yes, I think yes.
Yes,
Yes,
ma'am.
ma'am.
In formula itself we have seen this. I told you this is important. So
Yes,
Leibniz rule
ma'am.
is integration uv is uv1 minus u dash v2 plus u double dash v3 minus so on. If you don't remember, write down and understand. Where u is what? U is the first function, and such a function, how is this function?
E
Whose
raised to
derivative,
t.
whose derivative is becoming 0, derivable. And V is such a function. How is the function? Integrable function. If this is so, you can use Leibniz rule. You forgot. U should be such a function whose derivative should be 0. So which is U in this? In this two, which one is U?
T.
T. Because its first derivative is 1 and next will be 0. So this is your U. And V is integrable. Integrable sign, you can integrate sign. So this is V. Okay, so this is U. Once you will see the Leibniz rule. Then U into V. Integration U into V. It is U. U as it is, T as it is, into V1. Integration of sign. Integration of sign minus cos t.
Minus cos.
Yes, then there is minus sign, negative. U dash, its derivative of t is 1 into V2. V1's next integration, याचं पुढचं integration. Integration of cos,
Sine.
Sine.
integration of cos sine. But there is negative sign, so that negative sign as it is. Then minus, then plus. Plus derivative of this 1. Derivative of 1 is
0.
if it is
0.
coming 0, then this is over. This is the integration. Okay, this is for your reference. So it is equal to minus e raised to minus x cos t minus e raised to minus 2x minus t cos t minus minus plus sin t. But this is in t, it should not be in t. So resubstitute e raised to x. So replace t by e raised to x everywhere. Can we multiply this to minus minus plus e raised to minus 2x into e raised to x cos e raised to x? Once again this into this minus e raised to minus 2x into sin e raised to x. Here can be happen the multiplication minus e raised to minus x cos e raised to x. Basis same, addition minus 2x plus x minus x cos e raised to x minus e raised to minus 2x sin e raised to x. Minus plus same term, cancel. Minus of e raised to minus 2x into sin e raised to x is your required yp. Therefore add yc and yp. Is the general solution.
Ma'am,
Yes beta?
factor inside outside method ने ma'am सोपं पडेल.
Yes, you can do. I'm just telling you the both ways. Either you can use factor inside outside or you can use this is or. This is up to you what you want to use. I'm showing you both the ways. You just use any one which you like. Have you solved by factor inside outside?
Yes ma'am.
Good. Very good. You can do that. Any doubt? Please ask. Is there the problem with it that you cannot zoom to the full page, full screen? Any problem? Trying to zoom. Chalo, good. Any doubt? Next question. Solve. We'll write here. Solve b square plus a square y is equal to sec ax. Shall find the roots and tell me the roots, please.
Plus minus a.
Plus minus a. No.
0 plus minus AI.
Yes. Here we cannot use calculator, so shift to this side. Plus shift, so it is negative. And if you take the square root of negative term, there will be plus minus. And the square root a square is a, and square root minus 1 is I. Plus minus a. Therefore, by C. C1 cos ax plus C2 sin ax. We'll go to YP. YP is 1 upon d square plus a square into sec ax. How is the function? Does not comes under shortcut, so general method. For general method, denominator should be factorized. So what are the factors of denominator? Depending on the roots, you can write the factors. So here roots are ai and minus ai, plus minus, right? So first is plus ai and second is minus ai and minus ai. So what are the factors?
D minus AI, D plus AI.
Very good. D minus ai, d plus ai. Into sec ax. Okay, then we can separate the two by using partial fraction. So consider, call it as 1. So consider this 1 upon d minus ai, d plus ai, that is a upon plus b upon. Cross multiply a into d plus ai plus b into d minus ai is equal to 1, the numerator. Okay, then we solve it. What is the first substitution? Put d is
minus a.
Minus AI.
minus ai or ai, whatever you want. We can write first ai. Sure. So if it is ai, AI plus AI, 2AI into A, and here AI minus AI, 0. So A is what? 1 upon 2A. Second we put D is minus AI. If D is minus AI, it will be minus AI plus AI, 0. Minus
minus
AI
one.
minus AI minus AI, minus 2AI into B. Yes, so B is minus 1 upon 2AI. Right? AB's are here, so substitute. Therefore, D minus AI, D plus AI can be written as A upon. So what is A? 1 upon 2AI upon D minus AI. A upon plus B upon. B is minus 1 upon 2AI upon D plus AI. That minus, here is plus, here is minus. So in between, there is minus. Okay, therefore, put this in equation number 1. 1 becomes yp is, for this, we can write this. That is 1 upon 2ai into 1 upon d minus ai. This is multiplied, right? So we can write like this. Minus 1 upon 2ai into 1 upon d plus ai. Into sec x. Equation 1. For this, we have written this and then into sec. Okay, so we can separate sec with this, just multiply inside. Therefore, yp is, can you see 2ai 1 upon, that is common, so you can take it out of the whole bracket, 1 upon 2ai outside of both, then 1 upon d minus ai into sec x minus 1 upon d plus ai into sec ax. Such question will be there for your ISC exam or unit test. Whenever there is a write-up, you will get such questions. So pay attention. I know MCQ type exam is there, but for your ISCs वगैरह, such questions will be there. So you should pay attention. Therefore, YP is 1 upon 2ai, this is as it is, common. For this, apply the formula.
E raised to aix
Very good.
integration
Raised
e
to
raised to minus aix sec ax
dx. Right, dx. Whenever integration comes, write down dx. Minus. For this,
e raised to minus aix
very good. E raised to inside plus
aix
into sec x dx. This is the formula of general method. Then now we have to solve the integration. Okay. So here yp is 1 upon 2ai as it is. Outside part also as it is. Now integration we have to solve. If we see, there is e and sec. Neither of the functions derivative is 0. Not e's derivative is 0 and not sec's derivative is 0. So Leibniz rule is not applied. So you can think something different. We try to uh, simplify. We have one formula, e raised to minus I theta here. E raised to minus I theta is ax. What is that formula? E raised to minus I theta cos theta minus I sin theta. Theta is ax. Right here, e raised to minus I theta cos theta minus I sin theta. This is the formula. Okay. For this, e raised to minus of I theta, theta is ax, cos ax minus I sin ax into sec. Sec is what, but sec is 1 upon cos. 1 upon cos ax dx. This is done. We write for this. E raised to minus aix into e raised to I theta. What is e raised to I theta? This is e raised to minus I theta. And what
Cos
is e
theta
raised to?
plus sin theta.
Yes, cos theta plus I sin theta. So it is cos ax plus I sin ax into sec is 1 upon cos dx. Try to simplify. 1 upon 2ai e raised to aix integration. Cos upon cos. Cos ax upon cos ax 1 minus I sin ax upon cos ax. Sin upon cos
10.
tan. So this is tan ax dx minus e raised to minus aix integration cos upon cos 1 plus I sin upon cos tan ax dx. Okay, so now we can integrate as they are separated. E raised to aix integration 1 dx, that is x, minus I is constant. Integration of tan. What is integration of tan? Formula. Integration of tan x is log of sec x. Yes, log of sec x. So integration of tan ax is log of sec ax upon a. If a is there, that derivative should be in the denominator. Okay, this is done. First part. Minus e raised to minus aix as it is. Integration 1 dx is x plus I integration of tan log of sec ax upon derivative of ax is a. Is there any d? No.
No.
These are over. This is done. Integration is also we cannot see. So we can stop. This is your yp. Therefore, add yc and yp for the general solution. And if you want to simplify more, just write e raised to I theta, multiply inside, few terms get cancelled. If you want, you can do that. Again here e raised to minus I theta, few terms will be deleted and we get more simplified answer if you want. Homework: d square plus a square y is cosec x. Sec is done. You will take cosec second. D square minus 3d plus 2y is sin e raised to minus x. Sin e raised to x is taken, minus x is for you. Next one. D square plus 2d plus 1y is 4 e raised to minus x into log x. Okay, this is all about the general method. You try the homework. Can you just try this one? This two you can solve. Start solving this third. I am here only. I'll ask you the answer. Take your time. Solve third one. Start solving. If you have any doubt, please ask. Have you written the question? Third one. You are solving the third. 4 e raised to minus x log x. What are roots?
-1, -1.
-1.
Very good. So yc is c1 plus c2x into e raised to minus 1x. Go for yp. जमते का? -1 yc c1 plus c2x e raised to minus 1x yp 1 upon काय होतं ते d square plus 2d plus 1 into what? 4 e raised to minus x log x. 4 e raised to minus x log x. How do we solve?
One upon d plus one into.
Very good. Very good. Is it case number 5? Is it case number 5? डोकं चालवा नुसतं ही जनरल मेथड म्हणतोय म्हणून सुरुवातच जनरल मेथडनी करू नका. पहिले इथं पहा म्हटलंय मी. ही केस 5 दिसतीये का? तिसरा केस 5. हे e raised to ax into v दिसतंय का? दिसतंय ना? e into something. बरोबर? 4 तर कॉन्स्टंट आहे, बाहेर निघेल. दिस इज केस 5. e बाहेर निघेल, e raised to त्याचा पॉवर d ला ऍड होईल. काय त्याचा पॉवर? -1. So d minus 1 square plus 2 into d minus 1 plus 1 on log x. If you can use shortcut cases, please use it. They are for simplified. If you want to be simplified easily, you will use shortcut cases if you can. Yes, we can use, so we'll use it. 4 e raised to minus x. Simplify this. D square minus 2d plus 1 plus 2d minus 2 plus 1 into log x. Minus 2d plus 2d. 1 plus 1 minus 2. Cancel. 4 e raised to minus x into 1 upon d square log x. Now it doesn't come under any of the shortcut cases. Log is nowhere there. But if you can see, here is only the d square, and that d square is nothing but integration,
Integration.
right? So double integration of this. Integration of log x. What is integration of log x? We take one integration and we let other outside. Formula we have written, I think. Integration of log x. Integration log x dx is x log x minus x. Right there. X log x minus x. First integration of log x. We have to take one more integration. So it is 4 e raised to minus x into integration gets separate. X log x dx minus integration x dx. This we can do. Now what about this? How do we solve this? This integration. Can we use Leibniz? Oh, can we use Leibniz?
Yes, ma'am.
Yes, ma'am.
Okay. So use it. 4 e raised to minus x u x
X.
d log x. Right? So u x into integration of log x is x log x minus x. त्याचं पुढचं इंटिग्रेशन लिहावं लागेल. प्रॉब्लेम काय आहे, आपल्याला तेच इंटिग्रेशन शोधायचे आणि आपण पुढे तेच लिहावं लागेल. याचं डेरिव्हेटिव्ह याचं इंटिग्रेशन. म्हणजे हे वापरून चालणार नाही. शोधायचं तेच ना, पुढे तेच तेच लिहित राहावं लागेल. मग आता काय? लेबनिझ नाही. मग कुठला रूल? लाईट रूल. Log comes first. So this is u and this is v. काय? Integration uv by light, by not Leibniz, by light rule. U into integration V minus integration of derivative
So
U into integration V. This is the formula. Use it here. So what is by light rule? Which is your first function?
Log.
Log. L is log. So log is first. So this is U. And second will be algebraic. Algebraic is here. X is algebraic. So L is first. So this is U and this is U. By this U log X into integration of X dx minus integration of derivative of U, derivative of log X into integration of V X dx. This by this formula. Minus integration x dx is x square by 2. This is done. So it is 4 e raised to minus x log x into integration x is x square by 2 minus integration of derivative of log x. What is derivative log x? 1 upon x. Very important formula of integration derivative. You should remember. Derivative of log x 1 upon x into integration x square by 2, right, dx, as we have to take one more integration. This minus this is done, x square by 2 as it is. That is equal to 4 e raised to minus x square by 2 log x. इथे एक x कॅन्सल होईल बघा, x गेट कॅन्सल, 1/2 बाहेर येईल, minus 1/2 integration of x square by 2 minus पुढचा x square by 2 as it is. So it is 4 e raised to minus x square log x by 2 minus x square by 4 minus x square by 2. How much is this? 4 e raised to minus x square log x by 2. How much is x square? Minus 1 by 4 minus 1 by 2 minus 2 minus 4 minus 6 by 8 minus 3 by 4. Can you just check? Minus 3 by 4 x square 5. Therefore y is adjust yc and yp for the general solution. I'm at college right now, so I'm facing some network problem. Network issue is there. We'll wait for some time and we'll join back once it's restored. Please let me just check once. Is it back? Please wait for some time. I'll put the message once again and then we'll rejoin back. Wait for some time.